Alright, so guy 5 will come here soon, but let's just get started.
Okay.
So, problem 1, binary star system. By the way, how much have you guys looked at this?
No. Only a little bit.
Like, looked at it
Okay.
with my eyes.
That's fine. That's fine. This is my first time, but that's fine.
That's okay, yeah.
Okay, 2 stars, masses, initial positions.
This is pretty familiar.
Yeah. What is the initial momentum of the star system? So mass times velocity. And
you have the recording started, right?
Yes, recording is started.
Ooh.
So, well, I guess first we can do a free body diagram. Paint. Hello, paint. 2 stars. 2 circles. Oh, so we don't even need to calculate the gravitational thing, because it gives it to us.
Yeah.
That's nice. So...
I'm guessing you just draw the velocity vectors coming from each of the stars.
Yes. Yeah, towards each other. That... I'm going to turn you down a little bit. Okay. So the velocity vectors and... what else is there? Oh, well, the gravitational force vector. Wait, what? Oh, okay, sorry, they're presenting the data to us weirdly. Okay. So, kind of in this direction. And this one is... nope, that's the wrong way. This direction. Negative x, positive y.
Okay, so I did, other than momentum principle, what will we need?
Give me a sec, I'm finishing up the drawing.
Yeah, can you share your drawing to make sure we all have it the same?
Yeah, so I can share my screen again. That seemed to work out well. And whenever you guys have questions, you can just peek over. So this is going to be star A, and this will be star B. Besides the force of gravity and the velocities, initial velocities, is there anything else?
I don't think so.
Oh, and it would make sense that the stars have opposite velocities because they would be rotating around each other. Kind of, whatever.
Yeah, I see what you mean. Okay, so for the concepts, I wrote down momentum principle, position update, and then is there anything else we'll need?
Maybe gravitational equation, depending on how the problem's structured.
I'll just write it down.
Momentum principle. And what was the other one you said?
Position update.
Position
I think.
update. Cool.
assumptions.
No air resistance or friction.
No friction's a good one.
No air resistance.
Yeah.
We're in space, so I think that's
Yeah, there wouldn't be any. There shouldn't be.
No air resistance. We'll still put it down.
I'll just put no resistance. That counts for everything.
Right. Constant
And then
velocities.
we're not near any other large bodies
Yeah, it states that though.
of
Yeah.
mass.
Yeah, they mentioned that.
Besides
Oh yeah,
that,
that's mentioned.
I don't think everything else is pretty good.
Yeah. For the systems and surroundings, should we make star A or B the system?
What is the initial
think-
momentum of the binary star system? So it would be both of
So
them
it's
together.
both of them.
It's both.
So there's no surroundings.
Space.
Space. But right.
You get space for it. You get space.
I guess.
Beings. Space. Nothing. Well, the space isn't contributing force to anything, so I might actually just put nothing.
Sure. Okay.
Okay, and then what is the initial momentum of the star system? So the momentum would be,
Just multiply the initial
Velo-
velocity.
yeah, multiply the velocities by the masses and then add them together.
We wrote down the strategy, right? Or did you know?
Strategy?
For the
Oh.
second part of 3.
Oh. I've never done that.
Oh wait,
Whoops.
we don't have one, do we?
Did you say we don't have a strategy?
Well, no, as in like where we have to like write it down.
Oh wait.
Oh, never mind. It does. And
Yeah.
the core systems.
To get the whatever. Cool. All right, initial momentum was this just m1 times v1 plus m2 times v2, which I suppose I should write this down. MA times VA.
So this one you can just take the impulse equation.
What's
P
that?
equals F net T. Oh wait, never mind. Just realized. Disregard what I said.
Okay.
That doesn't have anything to do with your thing.
I think if it doesn't give you time though, you can calculate time if you do the distance divided.
No, we just have to multiply the mass times
Mass
velocity.
times velocity.
Oh.
This would
That's
actually
nice.
be, if you look at the center of mass notes, it would be the velocity of the center of mass. It would be, so the momentum's added up, divided by the mass would give you the velocity, but you don't have to divide by the mass, because it's one momentum. And all of this, we're gonna swoopity joop.
Wait, what did you just say? So you don't do each. So you add the velocities divided by the total mass?
Well, that would give you the velocity of the system, but we want the momentum. So what you do is you take each momentum and add it together.
Okay.
Right.
Okay, that makes sense.
Mm-hmm.
Thank you.
You're welcome. What the masses are, we're gonna slide this to the side. 4030. MB equals 2E30
So what did you guys get? Or
Give me 1 second.
Hi everybody. Sorry about that.
Hello.
Oh, hey, you're here.
don't worry about it.
So is this gonna be like the same as the one we had last week with deal?
What?
Similar.
What?
Wait, are any of you getting 0 for the system?
I am
the-
also getting 0.
Yeah.
I was confused.
Me too.
Okay, that makes
That's weird.
sense. No,
Yeah,
that,
because there's no surroundings.
well, no, I
There's
mean,
no force, right?
it makes sense because
acting on
the stars, if they're truly just orbiting each other, wouldn't be moving. They'd just be orbiting each other.
Oh yeah.
So,
So what do you mean?
well, so if you have two things spinning around each other and just spinning around each other, they would just be, they wouldn't, well, then their combined momentum would be 0
Would be
because they're
okay.
opposites of each other.
Yeah. Okay.
So, initial momentum is 0.
So initial moment. So it's just 0.
Yeah.
Okay.
Give me a sec to write this down fully, though. Yeah, I thought I did it wrong. Right, and so the final momentum equals the initial momentum plus our F net
Times time.
times delta T. And this is of the system. So there's the magnitude of gravity that each one exerts on each other is that, but we're
But it's equal and opposite, so it's
so
still
it's 0. So the final momentum is 0.
Okay, it's starting to make sense why this question has multiple parts.
Yeah. It'll probably ask us to change the system. Hey Chris, you said you had a class that you got held up in. Would it be better if we did this at 8?
No, I can do it now.
Okay.
I thought the class went till 6, but apparently it goes till 7:15. So I was like,
So what are we gonna put for the last part where it's like construct your argument? I never know what to put for those.
To justify the solution.
Just explain how like what Eric was saying, like
Yeah.
since they're both like spinning in the same way, but in like opposite directions. It's the. Sorry, I'm explaining it badly. Whatever Eric said.
So wouldn't it have an initial momentum of 0, and then
Yeah.
Mhm.
just a momentum after 1 week of 0?
Yes.
What's the initial momentum?
The combined orbit's momentum would be 0. Okay. And we're very confident in this answer. Gonna highlight that.
Initial momentum.
Are we ready to move on to part 2?
Yes.
Okay.
Yeah.
So part
Just
2.
finishing up the argument.
Right. We can wait.
Yep.
'Cause I'm also gonna transfer a picture over.
Would it be possible to do problem 2 tomorrow, Wednesday evening?
Yeah, depending on how quickly we get through this. But if you have to go, then what time do you need to be at?
Probably like 8.
8? Okay. Then yeah.
Sorry.
No, you're fine. We did that last week.
Yeah, that's good.
Yeah.
Okay, so part 2, it's asking for what is the initial
Star.
momentum of star B?
Star B. So
Okay, so we know we all calculated that, right?
Wouldn't the momentum of star B be the force of star A on star B?
the initial momentum would just be the velocity times mass. The momentum a week later would be influenced by.
Make sure you write down the strategy.
Where is the strategy? Oh, the general strategy.
But do we change the like system and surroundings because it's just asking about the
Mhm.
initial momentum?
Yeah, so the system would just be star B, and the surroundings would be star A.
Okay, so for a week, what would delta B or delta T be? Sorry. Would we do it in seconds?
60
Yeah, you have to do it in seconds.
Okay.
a week in seconds, 600,000. So 6.0 was six. You know what? I'll just put it in the Discord.
6 times 10 to the 5.
Here you go.
Fifth.
Are we still working on part 1?
No, we're moving on to part 2. Unless you want us to double back.
No. I have the answers, and I know how to get the solutions. I just have to do them now.
Okay. So, part 2. Momentum of B is mass of B times velocity B. That's the initial momentum.
And then the force would be force of star B.
Star A on star B.
Yeah.
And then I think it's also given too.
What? Whoa. Are we, for the initial momentum, are we taking into account the gravitational force?
No.
Okay, that's what I thought.
Yeah,
That would be
answer
if,
from part A, right?
yeah, I'll just take your answer from part A.
Okay.
What? Wait, what?
For it asks for what's the initial momentum of star B in part 2?
Oh, because you guys already wrote it down. Yeah. Right.
Everyone, negative 4.56 times 10 to the 42nd, and then 6.08 times 10 to the 42nd, and then 0, right?
4.56?
Give me
Yeah,
just one
negative.
second.
6.08? Yeah,
Yeah, so negative, positive 5, or 0.
got it. Yeah.
Okay, awesome.
4.56?
Negative 4.56.
Negative
Yeah.
4.5.
Cool. Cool. That's the initial momentum, and then a week later would be P of.
Oh, don't forget units.
Oh, why did you have to say
I
that?
figured, what's the units for momentum?
Newtons.
Kilograms,
So-
meters per second, right?
Kilogram meters per second, yeah.
Okay. That would equal plus.
And don't forget to multiply by 10 to the 34th. Is that 34th?
For what?
For the exponent,
10 to the 4th, right?
What?
the 34th. For the
34th.
momentum.
For what?
For the momentum, because when you do mass times velocity, like the mass is like 10 to the 30th, and then the velocities are 10 to the 4th, so it's 10 to the 34th.
Mhm.
For the momentum.
Oh, okay. I actually didn't notice that. Wait, so then my momentums are wrong.
What do you mean?
Because I just multiplied by the decimal and not the 10 to the 12th or 10 to the. Because the velocities are like 2.672. Oh, wait, that's position. Never mind. No, yeah, so velocity is like 10 to the 4th.
Mm-hmm.
But I didn't multiply it with 10 to the 4th to the decimal.
You just add it to the exponent.
Yeah.
So like 30, so 10 to the 30th times 10 to the 4th is just 30 plus 4, 10 to the 34th.
Okay.
Plus. So the force of gravity. Where are we adding that? How are we adding that?
So F net is going to be equal to. Isn't it equal to the change in position
F net?
or the change in momentum? My bad. Wait.
Over time, yeah.
The change in momentum over time, and then you add the force of gravity in the you have it oriented in the x direction. So that one would be in the
Wait, do we want it oriented in the X direction?
Well, that's what we have it as right now. It's not a big deal which direction it's oriented in, right?
I think it is. And the force, so they give us the positions, and it might actually work out to be a specific position, but the force of gravity is specifically towards the other planet. So I think we need to find the unit vector of position that in there, or from 2 to 1, from B to A. Find the unit vector of that.
Okay.
Or from A to B. There's going to be some sign differences. But
Sorry, what are we talking about?
so the force of gravity is a scalar, and we can't just add it, because so we have to find the direction that the gravity is being applied in, and the direction is along the unit vector towards the other planet, or I guess towards it from the other planet.
So is it B minus A then, or is it A minus B?
Yeah, that's a good question.
B minus A.
Well, so what is it's
Because like for the last week's one, we were determining the amount of force that was applied to the planet, so we put the planet first on the star.
Mhm.
So to determine the force applied to B, we put B first, and then A would be the second one.
Right. Okay, so the force being applied to this planet, we want to yeah. So A on B. So B minus A.
I have to find the unit vector first. Might take me some time.
Right.
And yeah, it's B minus A, I think.
Right. Oh, I did the velocities. Dang it. B minus. Divided by, oh, this is a long equation.
And then for part 2, do we have to do like a partial update type thing because it asks
Yes.
for the change in momentum?
Yeah.
Okay. And then for part 3, we just do the same thing we did for part 2, but this time it's star A.
Yes. Yes. And we can just Ooh. Oh, yeah, we can just flip the signs and it'll if we flip the signs, the momentums, yeah, we'll get it.
What do you guys go for the unit vector for position from B initial to A initial?
Oh, would that be B minus RA? Give me a sec.
I got 4 fists, 3 fists, and 0.
Okay.
Is that what you got?
Yeah, and then I multiply that to fnet to get the vector fnet.
I got for the x component, I got 9.68 times 10 to the 42nd.
Sorry, I'm in the process of calculating that.
Oh, you're good. Take your time.
Okay, for the first one, 1.6 times 10 to the 25th.
No.
Okay.
Did you multiply by... What did you multiply by for delta t? The number that he put in the chat?
Oh, that's for your, sorry, that's for your final momentum.
Not for my final momentum. No, I'm just working on the, like, gravity part.
The vector?
The vector? Yeah. Of gravity.
Okay, yeah. So I just multiplied it, I just multiplied the magnitude times the scalar. Or not that, I multiplied the magnitude times the magnitude of gravity times,
The unit vector of r?
yeah.
Okay, I did mine also times delta t.
Oh, okay. Let me try multiplying it.
Oh, you were just okay.
9.67 times 10 to the 30th.
9.67. Yep.
Okay.
Times 10. Wait, times 10 to the 42nd, not times 10 to the. Oh, wait a second. 1 second. Okay. I'm just dumb. It's okay. Because I still multiplied by 10 to the 12th, but that's not the unit vector.
Yeah.
So.
Unit vector would be.
What?
I think it's supposed to end up as the 30th, so you can add it to the.
Yeah, both of them are 30, right? To the 30th power?
Yeah.
Yeah.
Do you guys mean 34?
34 for what?
The exponent.
For
No,
fnet?
I got. What'd you say?
Are you guys getting those values for your momentum or for your unit vector?
Yeah, what are you guys talking about?
For
The
fnet,
gravity.
for the vector of, for the gravity vector.
It already gives you the force. All you need to find is the unit vector.
Yeah, but we were just making sure, like, when we multiplied them together, we got the same thing.
Ooh, Chris, are you done?
I wrote down like the stuff I need to do. I just need to calculate it.
Oh, okay, okay. Does anyone have an answer? Maybe we'll end up at the same spot. I'm confused at what step you're on.
I'm almost there. Give me, like, 2
Okay.
seconds.
Because if it's the unit vector, shouldn't it just be like
One. Yeah. Yeah.
Yeah, okay, so for the x component of the final momentum, I got negative 4.56 times 10 to the 39th.
39th?
Yeah.
Right. So, not what I got. I got 34.
34. Okay.
Wait, shouldn't you be ending in the 30th?
What?
Oh wait,
Okay,
I'm dumb. You're right. It's the 34th.
So the initial momentum we got was 4.56 times 10 to the 34th.
Oh yeah, my bad.
Yeah, that was my B. I just plugged it into my calculator wrong.
No, you're good. You're good.
So are you guys recalculating the force of gravity?
That's what we were doing earlier. Yeah.
Why?
Because it doesn't
But
it
we
give you
weren't
the
Because we need the vector format.
Yeah,
No,
we were like putting it in vector.
no. You could have just multiplied by the unit vector. So R2
Yeah,
minus.
that's what we were doing.
Yeah,
Oh. So wait. Okay. Anyway, let's.
we did the same thing. It's fine.
Right. What? And then kilogram meters a second. Do you think they'll take engineering format?
probably.
Okay.
I think this is physics for engineers, right?
Right.
Wait, what did you get for? What did you get for your Y component?
6.0807. We should be pretty.
To the 34.
Yeah, we should be pretty specific with these numbers because it's a very small change from the initial one. So
Okay.
instead of 4.56 to 4.559.
Okay, what did you guys get for the x component for the final answer?
I don't have a spot for an answer. Odd.
What?
I don't have a spot to put my answer.
That's weird. I don't think mine does either. Yeah, mine doesn't either.
Okay, well I'm just gonna highlight the final step. Okay.
So
Oh.
isn't it as... Sorry, go ahead.
I was just gonna ask, what did you guys get for the final velocity? Or momentum?
Minus 4.559.
Okay,
And then
You got
60807.
608. Okay.
Both times 10 to the 34th though.
Yeah.
Doesn't it want just the change in the momentum? I mean, yeah, you have to find the final momentum
Wait,
to get
what?
the...
It says
Like for
what
the
is the
portion.
initial also oh you're right, you're right.
That's
Also
like the
estimate the change in momentum. Oh, that's annoying.
Oh wait, so we just did all of that, and we just needed to do the
I mean
amazing.
we did a little bit of a
Wait, didn't we need that though?
We
Okay.
do need it though.
To calculate,
for the
yeah.
velocity.
for the velocity, the final velocity, corresponding change in velocity. No, we don't. That's epic. No one read the question, cause we're dumb.
I read the question.
Thank you, Audrey.
Thank
You're welcome.
Kinda saved us, yeah.
That's epic.
The chain, it was asking for the change in momentum and not the
Mm,
final.
Yeah, we gave
So
the
yeah,
fine. I mean, yeah, we can just subtract it and then, but it's still.
We just did it inefficiently.
Alright,
Amazing.
pretty awesome. Alright, 9.67 times 10 to the 30th.
Mm-hmm.
Alright, cool. Neat. That's the change in momentum, and then change in velocity is that divided by mass.
So what did you guys get again? 9.67 times 10 to the 30th is 1.25.
Yeah, times 10 to the 30th and then 0, yeah.
The change in velocity is minuscule.
Actually, it's the
Yeah.
change in momentum is pretty big.
Velocity.
Is it asking for change in velocity?
It's asking for both.
Oh. Never mind.
Change in velocity is like 4.8. During the first week, change in velocity, that's 1 over mass. Right, I'm not crazy.
Yes, you're not crazy.
Fantastic. Good answer.
I mean, I don't think you're not crazy. I wouldn't give you that, but that's my correct
You
answer.
did the problem correctly. Okay, what are we gonna put for our like justification portion?
Right. Momentum principle. What? Right. Final one. Or, I guess I don't know how much you guys are. If you're still writing, don't worry about it.
I'm ready for one.
The initial momentum of star A is going to be the only thing we need to calculate here. Everything else is just going to be the inverse of what we just calculated.
So what math did you guys do for the part 1 of this problem?
The math, mass times velocity,
Mass times velocity.
and then you add the momentums together.
Okay. But shouldn't it give you 0 as the momentum?
Yes, and it does.
And then, are we doing this again tomorrow?
Yeah, probably same time if we're good with that.
Mm-hmm.
Sorry about that.
No, dude, you're fine.
Wait, tomorrow or Wednesday?
Either would work.
Is tomorrow not good?
Tomorrow's good. I thought someone said Wednesday earlier.
No, I said I can't really do Wednesdays, but if we have to. But I'm good with Tuesday.
Right.
Okay, yeah, Tuesday's good.
Neat. But we still have one more part to do, and
Yeah.
it's very very short. So let's just get out of the way.
Break it out, yeah.
Cool.
first exam for this class?
Next week.
Okay.
Not next week. I think it's the following week, right? It's
Is it?
it's like the 28th or something like that.
28th would be Monday.
This Monday?
No, next Monday.
Next.
Today is
okay,
Monday.
okay. I was like, it's Monday. Wait, no, that's in,
2
it's
weeks
in
from now.
Monday.
Hmm.
Yeah, it's 2
It's
weeks.
on the
I was like,
28th. Okay.
Yeah, so
Yeah.
28 or 14 days from now, 2 weeks.
Next week is problem quiz
Everyone's
2.
first exam for this semester.
What?
Oh, I have a midterm Friday
Sam.
for.
Bio 395.
Oh no, I'm math 162.
Sounds a lot worse. Wow.
Good luck.
Thank you. I'm pretty
Sounds
scared.
Very different than mine, but you'll do well. I mean, I took 162, and if I can do it, you can do it for sure.
Hopefully. I don't know, the like the quizzes are easy, but like the homework is hard, really hard.
That's how it's always been for 162, though.
Okay, good.
Have you looked at the past exams?
Yeah, I'm in the process of it right now. I have it open.
Oh, yeah. I mean, if you can do the past exams, then you're good. And in fact, the quizzes are taken directly from past exams. So if you're doing very well in the quizzes, then you will do equally well in the exams. All else
Like we
equal.
have quizzes are a recitation,
Yeah,
and it's literally like as easy as a problem quiz was for this one,
right.
for this class.
Mm-hmm. Yeah. You got it. So, did we all get the initial momentum?
I did.
What?
Isn't this the same thing that we did in the first film?
Yes, except
Yeah.
without the other stuff.
Can we just put negatives?
For the changes in momentum and changes in velocity, yes. And in fact, that is what
Yeah.
I am doing. But for the for the oh wait, yeah, no, you're right. Everything can be negated. You're right. Yep. So yeah, everything's negated, and that should be the end of the problem.
Nice.
And that is because the entire system has a net zero momentum. Cool. Is everyone good with that?
Yes.
Nice. Cool. Well, if we're good with that, then now.
Okay.
Okay. Did anyone look at the problem? Yeah.
Yesterday, a little bit.
Okay. Basically, it's a pulling on an object at an angle with friction. So we need to find the magnitude of the frictional force and the acceleration of the object based on the force being applied on the rope, which is pulling it.
Okay.
So on I drew a, here, let me start. Let me just, oops.
I mean, I drew like a triangle for mine, kind of.
Yes, I will show you what I drew for the free body diagram, if I can figure out how. Here it is. Here we go. So kind of what I drew. It's, you have the object with the rope being pulled. The tension in the rope is the force of the pull. I just call that T for tension. Then I split the force into two components, x and y.
And we'll probably be only concerned with the x component,
Mhm.
right?
Yeah, but just for simplicity, I split it into two.
Okay.
Mm-hmm.
And then for our principles, we're going to be using the equations for friction. Do we need momentum principle? I think so, right?
Yes, I think so.
And then the force
Time
equals
for
mass.
acceleration.
Yeah.
Friction concept, and I think that's it, right?
Okay.
Momentum and friction.
Yeah, should we say something about like tension?
Sure. Yeah. Tension.
Well, tension is just a force.
Yeah, but don't we have to, or like, don't we have to split it into x and y, so it's like a little bit.
Kind of.
Yeah, it would still have tension force because she is pulling like a rope.
Mm-hmm.
I think.
I'm not sure. Okay. And
I mean, I don't
assumptions?
know that it hurts to put tension.
Yeah,
no,
I think it's fine.
Mm-hmm. I was listening to the rubric, and it said if you put tension, it's an automatic minus 20 points. So.
Mm.
Okay.
If you put tension, it's an automatic what?
Minus 20 points.
For what? For putting tension?
Yeah.
It's strict class.
Okay.
I'm messing with you. Assumptions and approximations.
No air resistance.
No air resistance. And constant pull force. And also constant friction. Cool. System being the sled and child. Surroundings being the snow and the rope.
Just really quick, you're recording, right?
Yes, I am,
Okay.
and I will double check that. Yes,
Sorry, I just want to make sure.
you are fine. And I will even double check and make sure I recorded the last one. What day is it? Yes. Yep. When I tried to upload it to Brightspace has a max file size upload of like 1/10 of what the video is. So I had to upload it to YouTube and then send a share link. I hope that's okay.
I'm sure it'll be fine. My other classes that I took over the summer, they only accepted like YouTube links.
Oh, really? Okay. Wait, do we even need the momentum principle? Because we just need to find the acceleration, which is the momentum. Or kind of, it's not the momentum, but it's the, yeah,
Actually,
we just need mass, well, mass divided by, or force divided by mass.
Force divided by mass, yeah.
So we don't even need the momentum principle. We just need to find the,
Yeah,
the
okay.
force and then divide out the mass. What the heck?
So it's just force over mass, right?
Force divided by mass is acceleration. Trigonometry 2. Okay. Are you guys on the solve the problem step?
Yeah.
Yeah.
Right. So the f of x, or force in the x direction, would be oh gosh, I'm blanking. What?
Just the cosine.
Tension force times the cosine of
Yeah.
40 degrees. And then that's it. So that would mean the force of friction.
Well, technically there is one in the y direction, but we don't care about that.
Right.
Oh, it's f of x. Okay.
Yeah.
Never mind. For f
So-
sub x.
Friction. Oh gosh, I forget the equation.
It's like the constant times
Normal force.
Times normal force?
Yeah, the coefficient times the normal force, I believe. For both static and kinetic friction.
Okay, so we do need the y value then, because the y value would end up being the normal force, right?
Yeah.
Okay, so... Wait, that doesn't make any sense, because assuming... Okay, say your angle was 0 degrees, there would be no upward y value force, but there would still be friction. So... What? Chris, you said you did this in the past.
So, let me think. So, since you're pulling two separate masses, I think that you'd have to do the thing that they did in class today, where it's like mass 1 is on top of mass 2, and then mass 1 undergoes its own like frictional force because it's sliding on mass 2. I'm not mistaken.
No, I think the child is holding on to the sled, so it might be one mass.
Yeah, I think it's one mass.
Or are you talking about, like, if you take, like, the child and the sled separately, like, the child is, like, mass 1 and the sled is mass 2? Is that what you mean?
Yeah.
Yeah, to solve normal force, it's basic. I think it's just gravity, but like opposite. You just
Yeah.
switch the signs.
Yeah.
So then we should be able to find them.
Oh yeah,
Tension, right?
it's mass times gravity.
Yeah, mass times gravity.
Oh.
So what do we use this the static constant for?
That's what I'm looking at right now.
Probably for the acceleration problem, right? Because then you find like the change. Is that important?
Okay, static is trying to slow you down. And what is kinetic?
Static
Static
like,
is when it's not moving.
yeah.
Yeah, so
Or when there's
static
no-
is trying to slow you down. But I think both of them act regardless of if it's not moving or not. Or moving if it's moving. Because there will always be static friction.
Count for the static friction. And in this problem then.
Okay, where were we? I was thinking.
We're trying to figure out if we use kinetic and static friction coefficients?
So
I know we
the
should be using static for sure.
The static is to check and see if it does move, I think. And if it's not above the static, then we can stop the problem right there because it doesn't move. But if it is above the static, I think then we can just we go to kinetic because it starts moving. But
yeah, I think
so,
we just ignore the static. In this one.
Okay. So we are moving for sure, because friction is significantly lower than the force.
So for friction, we did the static friction would be 0.2 times. We're doing mass times gravity minus the upward component.
Mass times gravity times what?
Mass times gravity minus the upward component, because it's the I just checked. It was the pretty sure it's the you have the weight mass times gravity minus the upward force times the friction code. The upward force would be the y component of the tension times the friction coefficient. So usually that would be just mass times gravity when there's a flat angle, but if we're pulling upwards there would be less friction, so we have to subtract out the force of the upward pull.
Wait, I don't think we're moving though, because static friction is
What?
No, wait.
Static is when we're not moving.
Okay.
So, but
Never
basically,
mind.
so you guys are doing 0.2 times what, 9.8 times, sorry, 0.2 times 50, the quantity of 50 times 9.8 minus whatever f of y is, which would be t, whatever the tension is, times the cosine of, or times the sine of 40. Right?
I'm confused.
I don't think that's involved in normal force, because normal force is simply the force from the surface you're on.
Right, but there is less if you're applying an upwards force.
Oh, right, yeah. Okay.
Wait, so wouldn't you just take F normal and then do like times that? Why are you subtracting them? Why aren't you just doing F normal times like cosine or sine of theta?
So do you guys see the equation I'm doing?
Yeah.
Yeah.
Right, so everything inside the parentheses is the, I guess, normal force that's being that has friction applied to it. And the force normally is mass times gravity, but if you're pulling upwards, you need to subtract it. Oop, got an email. You need to subtract the upwards force from it. I'm fairly certain.
Can't you just calculate like the X force instead of subtracting the Y force? Would that be easier?
The X force is unrelated to the friction.
Oh, right. Okay. Why did you multiply by 0.2? I thought we had to multiply by the
0.2 is the
kinetic.
This is static.
15.
We're checking to see if it moves. At all.
Okay.
Because I'm guessing.
Do we show that?
Yeah, because I'm guessing one of these it won't move. Otherwise, why would they give us 2?
True.
Because it's not greater than any of them. It's 98 with 0.2.
It's not greater than what?
It's 98. So it's still less than both of them. And that's without subtracting t sine 40.
Oh, okay. 0.2 times. Can only do this. I can't do math. Yeah, okay, 98 minus 0.2 t sine of 40. So with t being 100, newtons. Then it would be what? 98 minus, oh god, 200 times 20 times the sine of 40. What is 20 times the sine of 40?
The normal force is going to be really small because 100 sine 40 is really small.
Wait, 20 times sine 40
really
is
big.
12.856.
12.856.
20 point. Where are you guys getting 20 times?
0.2
Sine.
times 100.
0.2.
12 point. Wait, sorry, it was 12 point what?
Sorry, hold on. Let me see. So I'm gonna do 50 times 9.8. That's our gravity. 490 minus t sine 40, which is 64, times 0.2 or 0.15, which is 63.8586. Sorry.
Yeah, when you subtract that out, it's 0.13135. 85.135 newtons. Is the static.
I got 63.86.
20. Oh, wait, times 0.2? Wait.
Times 0.15.
Oh, what? Okay. Give me a sec. Okay, there's a lot of calculation. 5 times. Alright, yeah, so the kinetic force of friction you got for 63.858 newtons, right?
Yes.
Is that what everyone else got?
63.85, yeah.
Give
1
me
second. I did not get that.
What did you
I
get?
got 60.644.
How did
What was
you...
your order of operations? Because that affects your answer.
I did Like I put parentheses in for everything, but I have. Did you get 73.5 for
Yeah,
like the first? Okay.
I think so.
So
Yeah.
73.5 minus.
I got 74.5
Oh, for
for the T sine 40, right?
okay,
The
sorry.
thing before the T sine 40.
What?
73.5.
0.15 times 50 times 9.8.
Oh, I didn't do the 0.15 until the very end. I did 50 times 9.8, and then I subtracted that from T sine 40, and then I multiplied by 0.15.
Plug something in wrong. Let me try again. 63.858. Is that what you got? Okay.
Yeah.
Yeah, I got that.
For T, did you plug in 100 again? That's what you do, right?
Yeah,
Yeah.
yeah, for kinetic friction.
Okay, and then after that, we need to we have our net force, right? So we just subtract 63 from whatever the x component of T is.
Well, hold on. I think we might have answered one of the questions. The magnitude of the frictional force exerted by the snow on the sled.
And now we have to do the acceleration of the child.
So, yeah, okay, so that's one of our answers. It would be, well, frictional force. Are they talking about static or kinetic? If it's kinetic, then we have the 63 or whatever.
Frictional. Or kinetic. I'm pretty confident.
Alright.
Because that is
Yeah,
our...
kinetic.
Yeah. What did you guys get for your x component for T?
Oh. Oh, it'd be 100 cosine 40.
Yeah.
By the way, this is all t equals 100. I think we need to redo this when t is 140. Redo everything.
Mm-hmm.
Yeah.
Wait, the acceleration would just be the force times... Yeah, force times mass.
Force divided by mass.
Force divided by math.
Yeah. But I
So
think...
what did you guys get for the force and for the x component of force for T?
76.604. That's what I got.
For...
Okay,
Sorry,
yeah, I
what,
got the same.
what was the question?
What you got for the x component of T?
Oh.
Actually, you're doing a lot better.
Who is?
You.
How am I doing a lot better?
You just have everything ready for like the final calculation.
Oh.
Oh, by the way, don't
Good
forget to
brain.
subtract by
frictional force.
friction.
Right.
Yeah.
Right. So force would be, yeah, so x component minus friction. Force of friction kinetic. That would be 76.6 is what you guys got for the x direction force.
Yeah.
Minus the...
Okay, my acceleration is really small.
I mean, you're pulling
60
someone on a
through
sled, so I
point.
think that kind of makes sense.
I don't know. I'm in California. I've never seen I've never lived in snow.
Right. Snow is this white fluffy powder that is very
Well,
cold.
yes, I know. Like I've seen snow, but like I've never pulled someone on a sled.
Nah, I'm just messing with you. Okay.
I was born in Ohio though, so kind of ironic.
Nah. Divided by mass.
Okay, I got an answer for acceleration.
I also got an answer.
0.255 meters per second.
Yeah.
Yeah.
Mm-hmm. See, this is dangerous because if we do the problem wrong, we're doing it all together, so we'll probably get the answer wrong. But
We're all in this together. It's okay.
Yeah.
yeah, okay.
Wait, isn't it meters per second squared?
Yes, you are correct.
I think your voice cut out.
Meters per second squared.
Sorry, this is on US West. I'll change it later.
Hmm?
You guys like the audio quality is kind of low for me because I'm US West. I'll change the server.
Oh, wait, do you mean US East?
No, this is on US West because I made the server.
Weird, okay. I mean, I thought everything was fine, but if it sucks for you, then sorry.
That's fine, don't worry about it.
You do whatever you need to, so you can hear my lovely voice. Right.
Okay.
So.
And we can just quickly calculate the other one with recitation.
Mm-hmm.
Is that all we have to do for this question?
Yeah.
Yeah.
Oh, amazing. And then we have to talk about the lab, don't we? Can't
Yeah.
forget that.
Yes. Yes.
Yeah.
So we'll do friction at 140 newtons, which, joke's on you guys, I'm just going to change one number.
Oh. Okay, Mr. Computer Science.
Nerd.
Okay, so the problem is, I think friction is negative for me.
What? No.
Yo, what?
Hold on.
Did you do it right?
Never mind. False alarm.
I really hope not, because I would probably start crying.
Yeah, that's fine. Okay.
Imagine if we had a negative friction. I would drop. Is it too late to drop? I think it is.
Oh my god.
Are you going into engineering?
Yeah. It's fine. I mean, like, drop out of college? It's
Yep.
not too late.
Oh yeah, that's not too late for that.
It's never too late to drop out.
Always welcome.
Alright, did you guys get...
No, we're not there yet. I can already tell you we're not. Mr. Coder.
If you want, you can skip some steps. 60... Wait! I am getting less friction, but that makes sense. Someone confirm that that does make sense.
Yeah, I'm getting less friction by 3 newtons.
3 newtons.
Yeah,
I
that's
have
the difference.
80 point something.
80.
I have 60.001.
You guys are both correct. One of you did static, the other one did kinetic.
I did static.
I did kinetic.
Mhm.
Are we
Do we
doing
not need to
kinetic?
calculate static too?
I think we need to
I
do
thought that was
both.
part of the question.
Mhm.
It is?
It just says friction, so I'm just gonna guess
So it's-
that we need to do both, but it literally just
Yeah,
says
I
friction.
don't know why they would give us both if we weren't supposed to do both.
I thought they would make us check and see if it moves, cause like that.
I wonder if only the kid undergoes static friction because the kid's not moving in the system. whereas the sled is moving, so it would
So,
undergo.
wait, I know what you're talking. They did that with the boxes, but
Yeah.
the acceleration of the child and sled, and then the frictional force on the sled. But like, even though the sled has a mass of 5 kilograms, the weight of the child is definitely contributing to the weight of the sled.
Yeah, because it's still part of the system.
Yeah.
But I wonder if that's why they gave us both, because they wanted us to think like, oh, the kid undergoes.
I think it's just to confuse us.
It doesn't actually apply to the solution because the child's acceleration is equal to that of the system's acceleration.
I'm pretty confident that's just to confuse us.
I wanna say that it's that we can disregard it.
Yeah, I think we can disregard it because it wouldn't apply to any of our solutions.
Yeah.
Okay, what did you guys get for acceleration?
0.945.
Yeah. Okay. So it's asking.
You got what?
0.945 meters a second.
That is not what I got.
What did you get?
Maybe I'm tripping. I got like 0.33, but I'm not really sure how I got that.
0.33. Okay.
Oh, I plugged in 100, not 100. Oh, I'm stupid. It's fine.
Oh, okay. That would make sense.
Yeah, I plugged in 100 instead of 140.
Okay, answers. Can I just... I highlighted them through my work. Can I just say see highlights?
Yeah.
Okay. Because they're all very clearly labeled. I just don't want to copy paste 7 things. 6.
Don't forget units, guys. I don't know. I know I just realized I've been forgetting that.
And we are very confident in our answers.
Debatable.
Did you say false? Yeah, I definitely don't really know what's going on, but you seem very confident, which makes me confident.
I am confident that we got something right.
Well, okay.
No matter what, I am confident that this is the answer I'm submitting. So.
Yeah. We will get a score on this, and I am confident.
Did you guys take
that.
physics in high school, by the way?
Yeah, but it was sucky physics. It was like fake physics.
Yeah.
To be fair, it was...
Because I think I've done this problem before.
I mean, yeah,
really?
I've done this problem before too. And
yeah,
whenever
I literally remember this. Not the same numbers, but like the same exact situation.
Yeah, when I did it, my teacher always made us check because he would throw in stuff where the force was not at all enough to overcome the static friction.
I'm just not excited for once I have to start doing derivatives.
I am.
I
got
a 4 on AP Physics.
I'm gonna be so much
Give
easier.
me credit.
Of course you love derivatives.
I mean,
I'd much rather be doing calculus right now. Like, I cannot do actual physics where you need to understand things.
well, what sucks
I'd
is
rather be doing this.
they're making us do calculus but manually, and that sucks. Like, I don't want to calculate the acceleration and then the velocity and then the position. Just give me the calculus. That's way easier.
Yeah.
Do that in one step.
Yeah, this is more
Okay,
algebra
Mr.
based, I
Computer
think.
Science.
I guess I just have to remember it though. That's the issue.
Mhm.
I took calculus 2 years ago, and I barely remember it.
So the frictional force is just the kinetic in this case, because the sled's moving, right?
I did
Yeah.
both. I did both because it starts off not moving. So I did static and kinetic.
But then wouldn't Fnet, if we calculate it when it's not moving, wouldn't Fnet be 0? Technically there's, oh wait.
Oh my god.
What?
I'm getting like 70
Oh, you're getting,
bajillion.
oh, I see that. That's
What
funny.
the heck? My computer decided
Get a
that
Windows
right
update,
now.
by the way.
Thank you. I will probably never restart my computer. I don't know why, but my computer just thought that right this second was the time to give me 19 notifications.
Hey,
So what's our argument for this?
Force equals mass times acceleration. So to find the acceleration, take force divided by mass. And
I also
force.
talked about Newton's third law. I just like briefly mentioned it.
What is Newton's third law?
I'll be right back.
Isn't that F equals ma? Isn't that the whole point of Newton's third law? Maybe it's Newton's second law. Let me see which law it is.
I don't even know.
Just say Newton's law.
There we
You
go.
don't have to say 1, 2, 3.
It's Newton's second law.
Second.
My bad.
I really don't know what else to say for why we did what we did. I mean, we just did the equations. And the equations we did were force equals mass times acceleration.
I guess we could talk about like the trig involved. Like, so we only focused on the y for normal force. We only used the force of y.
Okay. This case was right. All right. Well, Neato Burrito, I say good job, guys. Glad to finally have this done. Again.
Very glad to have it done, especially early in the week.
Yeah. Yeah.
Alright, now time to look at the lab. So,
Oh, right.
yeah,
Here, I'm gonna stop the thingy. Goodbye.